Hi, everybody. My name's Tim Quinlan. I work for Red Hat. I'm a technical account manager there, which means I herd a lot of cats. The main thing I work with is OpenStack, and then obviously RHEL. I mean, everybody there works with RHEL in one way, shape, or form. However, this talk is not about Red Hat. This is a community-oriented talk, so there's no branding or anything. That's why we have the very generic-looking slides. So this is the warning about it. This talk is about setting up a virtual on-premise lab using VMs to simulate data center hardware, not necessarily a traditional virtualization talk. This stuff will never perform well. This is for learning purposes only. So don't do it, or don't do it in production, I guess I should say. Well, like I said before, yes, I work for Red Hat, but this is a community prezo, so this is not supported stuff. So there's a lot of talks today about cloud computing and infrastructure as code and everything like that. How many of you guys are absolutely brand new to cloud computing, never touched it before, ever? Okay, a couple. Okay, good. How many of you guys have on-prem cloud computing right now? Okay, and what about out Amazon, anything like that? Okay, what about a hybrid? What about a mix of those? Okay. So basically, I give this talk, I give a branded version of this talk to customers all the time, which talks about how to do this with the data center level hardware that you have. You know, how to do this with your big Dell computers and things like that. But we don't all have that in our basement. So if you want to get started with it, learn how it's done, learn the basics, this will get you going. So what the heck is IAC? IAC is infrastructure as code. It means that we are defining our infrastructure with templates, with facts about our machines rather than having a manual process, right? We are going to install an OS on a machine, and the only thing we know about this machine is its MAC address, right? We're never going to go walk up to that machine and pop in a USB disk or USB drive and, you know, install it manually or even use Kickstart or anything like that. So this is primarily for cloud computing, and there's different levels of IAC. It's often confused with infrastructure as a service. As we'll see when we go through the demo, they are pretty much the same thing, but they're just at different levels. Okay, so yay, there's a heart-shaped cloud. But this also works good for high-performance computing is another good thing. I think if you get the gist of what I'm talking about, you'll be able to adapt it to your specialty. So infrastructure as code versus infrastructure as a service versus Baremetal as a service. These are kind of three things that build on top of each other. We're going to be focused on infrastructure as a code today, and that's defining and controlling your physical infrastructure with declarative information. Infrastructure as a service is what runs on top of that. So we're going to be using OpenStack today. Anybody ever heard of OpenStack? All right, who's using OpenStack right now? Nobody. You are. Okay, I know you. You work. You don't work. You probably use somebody else's OpenStack from what I know about you. But anyway, I'm going to start throwing stuff out as I start throwing terms out. Anybody ever hear of like RDO or anything like that? It's kind of the upstream of Red Hat's OpenStack. But then again, you know, you can do other stuff like OpenShift or, you know, whatever on top of infrastructure as code. Then you have Baremetal as a service, which rides on top of infrastructure as a service, and that is actually using Baremetal resources as cloud resources. So a user would be able to schedule, you know, a big honkin' server to do some scientific calculations, the same as they would be able to schedule a VM in OpenStack. So, you know, why do we want to do something like this? You know, flexibility. You know, you can power off a machine, boot it back up with a different image, and it can be a completely different machine within minutes. That can lead to scalability. Say you have whatever percentage of your fleet is dedicated to whatever development or whatever, and you need to scale up prod in a hurry. You can always knock down some of your dev and bring it up with a prod image pretty quick. Density. Overall, you need less hardware to do what you're doing, and this is all on commodity hardware. One of the kind of tenets of cloud computing is using the cheapest hardware you can and using a lot of it, right? Spreading the load out. So KVM is what we're going to use. We've got some KVM users, libvirt, things like that, okay? That's what we're going to use as the basis of our demo. We need one virtual network on our KVM host that is just stripped bare of everything, no DHCP or anything like that. And then we need a way to power cycle our VMs, right? Virsh won't do it or Virsh won't cut it in this demo. You can kind of manually use it, but it really will not do the job. So out-of-band management is where we're headed here, being able to run IPMI commands on the VMs themselves. So hardware BMC, DRAX and ILOs. We know about DRAX and ILOs? Yes, no? Okay, basically, they're, virtual KVMs or however you want to think about it. Keyboard video mouse, I guess I should say. It's an out-of-band connection. It doesn't go over the operating system. It's a separate NIC in the server that allows you to connect to the server. So if it's down, if it's off the network, whatever, it's essentially like walking up to the server and logging on, with a hardware console. And you can also do things like, issue power commands and stuff like that. So we are going to use, for this demo, and then if you do this and build your own lab, VirtualBMC. It's a Python program that uses libvirt commands, right? So you can issue commands to your VirtualBMC to power cycle your VMs or change the boot order. Those are the two big things we need to do to them, okay? It's really simple to install. I'm not going to demo installing it because that's always a good way to fail, is relying on an internet connection to do a demo. But basically, there's a couple of there's a few packages here. You install some Python packages, whether it's on a Fedora based or a Debian based distro. Those are your packages you need. You install it with pip, and you basically just do this command down here, this VirtualBMC add whatever it is, the VM name. Whoops. Can't copy and paste. We're in presentation. Sorry. You would add the VM name. You give it a port, right? You give it a username. You give it a password. You tell it to use libvirt and to listen to QEMU/SSH commands and where they're going to be coming from. And then you just start it up. So if we look real quick at our machine, you can see that I have a couple already prepped. It's almost like I planned for this. Oh, yeah, you're right. Thank you. Is that better? Let's see if I can. Okay, so we have these two machines sitting here. So let's sprinkle some magic dust on these and pretend that these are not VMs. We're not going through any sort of libvirt API or anything like that, right? We're going to issue an IPMI command to them. We're going to pretend that they're real hardware. And what we can do is we can issue IPMI tools. We're going to go over LAN+. Here's the username, the password, the host, the port, all this stuff that we did in our setup command, and we're just going to try to get the chassis power status. We can see that it's off. Let's see what we can do here. Let's say on, and then one of these look at that. It's magically turning on, right? ignore the man behind the mirror, or behind the curtain, I guess, I don't know, right? So that's basically it, right? I mean, that's the gist. I mean, honestly, it seems as simple as that is kind of the basis of infrastructure as code, and like the basis of like the hardware infrastructure that underlies any cloud that's out there. It's being able to, it's kind of beyond lights out data center. It's like no touch. You really don't care. You don't know, right? What the machine is at first, anyway. So now that we can do that, what do we do? Like I said, I work with OpenStack on a daily basis, so I chose that. There are two components to OpenStack, OO and Ironic. OO stands for OpenStack on OpenStack. It's what we use at Red Hat to provision OpenStack clouds. It's kind of a bare bones implementation, single node implementation of OpenStack that uses Ironic to actually fire up these machines and boot them up and install everything. So the product name of this is actually called OpenStack Platform Director, but essentially if you look at RDO or the upstream stuff, it's OO and Ironic combined together. So why did I pick it? It is heavy. The director node needs like at least 10 gigs of memory. The controller nodes need like 8, and the compute nodes need 4. So that's 22, 24 gigs of memory already that you're up to. But luckily, my machine has enough memory, but it has everything we need, right, for this demo. So if you are familiar with something else, once you get VirtualBMC installed, you can kind of run with it, right? If you can imagine, if you're good with PXE booting and DHCP, you could create a DHCP entry that has a TFTP image in it, and or TFTP served image, and fire up the machine. When that MAC address comes online, you boot it up there. So it's basically what OpenStack does. So for OpenStack typically likes things in threes, at least at the controller level, but obviously we don't have the space to do that here, so I'm stripping it down to one controller and one compute node. In OpenStack parlance, we have the director, which we've already talked about. That is the machine that deploys the stack and kind of manages it. And we also have two node types at the very basic, or the very least. The controllers, they control the networking and things like that, and storage. And the computes, which are your dumb hypervisors. Right. So we need to provision these controllers and these compute nodes somehow. So remember back to when I talked about the requirements for the lab. I said, you need to have one virtual network on your machine that has no DHCP or anything like that. This is where we're going to use it. We're going to use it for provisioning. The reason we want it stripped down is because the director node takes care of DHCP and TFTP and setting up the PXE environment, right? So and the DHCP config can change depending on what director thinks that node should be doing at any given time, right? If it's just there, it's never been deployed. Obviously, there's going to be a TFTP boot and a PXE boot image waiting for it, right? If it thinks it's deployed, it's not going to be there. So the virtual server config, right? Like I said, we're using VMs here. The two, obviously, you have to have enough memory for whatever workload you're doing. But aside from that, keeping your NICs straight, making sure that the NIC you're going to use for provisioning is on that provisioning network that has no DHCP on it. If you try to do this over the LAN that you use all the time that has DHCP, you might, you're not going to have a consistent hit as far as successful PXE boots, because sometimes it's going to get its DHCP from the director, sometimes it's going to get it from your router or whatever. And then obviously your your NIC that you're going to use for provisioning has to be bootable. So, I talked earlier about we don't know much about these machines when we first start out. We're going to use some sort of a declarative template to find out what it is, right? So this is it. This is all, actually this is a little bit more than you really need to know about a machine to get it up and get it installed when using OpenStack. The name is just the name that it's going to show up in the stack as. That has nothing to do with what the machine is. We need to know what kind of power management we're using. We're using IPMI in this case. And that could change depending, right? If you have a ILO or a DRAC card there, you could use the native drivers for those. Or you could use IPMI in some cases. The MAC address, that's the MAC address of the provisioning NIC on the target, right? That's really the only thing that we really need to know about the machine, right? That's a unique identifier. And then there's the PM login info and where it is on the network, what port it is. And then the last one at the bottom, the capabilities. This is purely an OpenStack thing, but it says to use a profile of control. That means that this particular machine will be a network controller, and then the boot option will be local. You don't need to have that in there. You can do that after the machine's been introspected or pulled in. So why do we do introspection? Well, actually, let me back up. When we look at the full example, there are going to be different types in there. Okay, so some have more memory than others, or maybe more CPU than others, or whatever. So introspection, it tests IPMI, right? Obviously, it issues the commands that you would need for a production implementation. It tests the PXE booting. It tests the hardware, make sure it's up and working, and then it inventories the hardware, which is always very important because if you have different machines with different capabilities, they may have different roles. Okay, so let's just jump over to a demo real quick. We already saw the basics of power management. So here we are. We are the stack user right now, and I have my cheat sheet up here somewhere. Okay. So I'm not used to typing OpenStack. I have shortcuts in my profile. Okay, as you can see, this is our director node. We have no Baremetal machines in this stack yet, but we do have this JSON file that looks just like the example we looked at. And you can see there are two nodes in here. This one here is going to be our controller. You can see we have it tagged already. Its capabilities are already tagged as a controller. And this one down here is going to be our compute node. Like I said, you can do this after they're pulled in already, but I always just do it right off the bat, especially if there are differences. Now, if you're using the same machine the entire way across, it doesn't matter. You can kind of let it auto-select at that point. So we are going to, and I am going to cheat here. Over cloud node. So, and we're going to import the information about these two nodes from this JSON script. Let's take a couple, maybe a minute or two. Okay, so there they are. So if we look at them, we can see that there's a couple of nodes there. Everything in OpenStack gets a UUID. It just makes it really easy to not confuse stuff. There are certain things where you can obviously get the names a little too close or even the same in certain cases. So if we look at this machine, All right, it's gonna see. This makes the big font kind of not fun. You can see it has a little bit of information about it. There we go with the driver info there at the bottom. All the information that we've put in already, what the password is, where it is going to be on the network, things like that. But it's really not fleshed out at this point. What its name's going to be in OpenStack is in there. This is all just stuff from the template, right? There are its capabilities right there at the bottom. Once again, we haven't touched the machine yet. The only information that's in here is stuff that's stuff that was in the template already. So we can use an introspection command. Oh, and the other thing is you can see that in the state field here that they're listed as manageable. That means that we can actually do something with them. Man, I can never spell this. So there's our introspection. So basically, like I said, this is gonna fire up our machines. Like I said, now we are pretending here that these are actual, real physical servers out there with baseboard management controllers on them. These are not VMs for this purpose. So what's happening? I'm not touching anything. My hands are right here. There goes the next one. And you can see, there we go. There's some Pixie. Put that one. Yeah. There we go. It's firing up. It's going. There goes the next one. You can see there's all the Pixie information. You could see the network interface or the IP address that it was getting its image from, which is the controller VM here. And this is going to go for a couple minutes. Basically, what it's doing here is inventorying the hardware. So we'll let this go. Does anybody have any questions at this point? Shoot.
So I saw that when you spun these out, the password was already on the command line.
Yeah.
Is there a way to not do that?
I don't know. This is very labby, right? Like I said, this is not for production use. This is getting to learn it. I'm sure if you look in the VirtualBMC documentation, you'll be able to find that answer. I honestly don't know. I've never even considered it. And you can see that the username and password that I used was admin and password. So I'm obviously not concerned with security in this thing. These VMs do not. I mean, they're behind a NAT, right? There's nothing coming into them. So here, have a koozie. Whoops. Any other questions? Go ahead. It depends on what you're loading up. OpenStack's pretty heavy duty, so this is going to use about 22 gigs of RAM. But if you're doing something where you have an image, and you're going to Pixie boot them, it's whatever those VMs would need to boot. Here, have some stickers. Oh, are you Red Hatter? Oh, okay. Any other questions right now? Now I see. He's waving them off. Well, here, you can have his stickers. Here you go. Since you sat right in front, you can have his stickers. There you go. Anything else right now? Okay. So, go ahead.
Forcing a hardware profile? So like saying this is an Intel chip or this is an AMD chip?
Well, I mean, I guess it depends on what you're using to utilize IAC. With OpenStack, you don't want to do that. You don't want to put false capabilities on your nodes. But yeah, I don't know. Why would you want to do? Just out of curiosity. I mean,
if you were trying to test your software in various different hardware types.
Well, I mean, if you were using QEMU and you said, hey, this VM is going to be something else, it's going to emulate some other architecture, maybe that's where you would want to do it. Here, what size t-shirt do you wear? Thought I had these. I had these out. Here's a small. There's a large. Power of deduction. I don't have much of an arm. So at this point, oh wait, I wanted to show you one more thing. Oh, and I'm just typing O here. That's just I just do that as a alias because I don't. It saves me a lot of keystrokes. So here we go. These are the same nodes. I've got the same UIDs. You can see in the provisioning state before they were manageable. Now they're available. This means that they can be scheduled by the director. And if we look now. We look at that same machine we looked at last time. We can see that there's a lot more information in here now. Specifically, the hardware type and the hardware properties. So that machine has 10 gigs of RAM. It's x86. It's got a 49 gig disk, it's got 2 CPUs, and on and on and on. Right? So if you look at and like I said, this is a very basic installation of OpenStack. Whoops. If you look at the different kind of the flavors in OpenStack, these are the different kind of nodes you can have. And you can see that they have the minimum RAM requirements and the minimum disk requirements, minimum CPU requirements. These are not real numbers, obviously. A controller won't even. You can't even install a controller if it has less than 8 gigs of RAM. I just have these all turned way down, just because I'm working with VMs here. But if you tried let's say we introspected a node that only had 2 gigs of RAM and you tried to say it was a controller, OpenStack's going to tell you no, you can't do that because it doesn't have the requirements of the flavor. So now we have everything there. It's inventoried. It's available. If we had a couple hours, we could now deploy. I keep trying to highlight stuff here, and I keep forgetting I'm in presentation mode. Sorry. If we had a couple hours, we could actually deploy a stack out on those machines. It takes a while when you're doing it with VMs. Like I said, don't expect this to perform. This is learning only at this point. And obviously, you don't have to do OpenStack for this. If you have something else that can take advantage of being able to manipulate those VMs, go for it. So OpenStack uses what's called an overcloud image, right? And that's the image that the controllers and the compute nodes will get installed from. It's just a base image they all use. If you're going to be doing Pixie, whether it's OpenStack or something else, these rules will apply. So you're booting from an image. You want to you're going to have to customize the image, right? At the minimum, you're going to have to set the root password because if it doesn't connect to the network when it boots or whatever, you want to be able to get in there and troubleshoot it. But I tend to set the root password, and I will only modify stuff that will break boot. If you're using one of the Red Hat images that has cloud in it and it's not a cloud resource, right, or not a cloud VM, it's really going to slow down boot. So you can use like guestfish, things like that, to actually fire up the VM or modify the file system of the VM. You could fire the VM up and manually do it, whatever. And if you are going to have any sort of customization in your hardware that you're deploying with IAC, you want to rely on some sort of post-installation tooling, right? Puppet, Satellite, Ansible, whatever. Have something in RC Local or something in the image that says, hey, once you're done booting, reach out to this configuration server and have it manipulate you and do your thing. And then get rid of that entry from RC Local. Something along those lines. Let me see how I'm doing on time. Like I said, for those of you who came in after the talk started, I have another one right after this, so I'm kind of zipping through it. If you have, and this doesn't necessarily apply to this this demo that we're doing, but this is a good practice, is to use the root disk WWN and set a hint, a root device hint. This way you'll prevent the automatic provisioning of blowing away your data. So, let's say that you set up this lab and you learn how to do this, and you come up with a way to pixie boot these machines and say, well, today this machine's going to be a dev machine, and tomorrow I'm going to fire it up as a prod machine. You might want to just wipe out the root disk and install the different OS with the different packages, different config, whatever. There might be other disks on there that you don't want to blow away, right? So if you use root disk hints, that makes it a little bit safer. If they are truly dumb, like compute nodes or like HPC nodes or something that don't really have anything except temporary local storage, then you don't have to worry about it. Once again, prod machines are going to have multiple NICs. To have a really, depending on what you do, for OpenStack, there are 5, 6, 7, 8 VLANs that you can run. I think the minimum recommended, I think, is like 5 different VLANs, and you're going to have different NICs. Some are going to be bound together. Anyway, you don't want OpenStack just randomly selecting your NICs because they're all going to be attached to different VLANs. So you can use NIC Config Templates. This will tell Director which NICs to use for which purposes, and where they go in the infrastructure that you're building. So we talked about infrastructure as code, infrastructure as a service already. Infrastructure as code in this context, it is deploying those machines out, getting the hardware out there, and making them available. We talked about deploying OpenStack. That would be infrastructure as a service on top of there. That is making resources available, typically VMs and networks, to your users. There's another layer called Baremetal as a service, which uses Ironic, which we talked about with Director. And this basically takes the Baremetal nodes that you define, however you define them, and you can make them schedulable by the users just like a VM. It uses Ironic. The networks and everything is controlled by the controllers, just like it was a VM, but it's actual real hardware. I just threw this slide in after we went through the two other examples of the two other layers, just to kind of differentiate them a little bit more. Now, if you want to set up a lab and you don't have one machine that has enough memory, right, to run however many VMs you want to do, or have enough memory to run an OpenStack instance, you can do this across multiple machines. What you do is basically have an extra NIC in each machine hooked up to whatever, like a little unmanaged switch or whatever, almost just for provisioning. So each VM, the provisioning network card in that VM would be linked to that it would be bridged to that physical NIC, and then that way they're all on the same LAN. The only caveat with this is the control node. The control node cannot be one of the hypervisors, right? Because when you're bridging, when you have a bridge connection, the VM can't always talk back to the host, right? So you can make it a VM. The VMs can talk to each other, but they can't talk to the host. So if you're installing the controller software directly on your hypervisor, it probably wouldn't work with this way. But you could always just set up another VM with that software on it. And that's it. Here's my contact info. There's my GitHub. I'll put all the example files and the slides and everything up there. I synced them up last night, but I made a few changes here at the last minute, so I will get those going. So, any questions? I still have T-shirts and a hat, so they go to people who ask questions. All right, go ahead.
I'm not an OpenStack expert at all.
Okay.
Or
I only play one on TV, so.
I don't even know. So I saw you turn on and off the power.
Mm-hmm.
Does it mean, say, if we deploy in a, say, AWS, we can avoid the charge by turning it off?
I don't know. Max, you might be able to answer that. Can you issue IPMI commands to AWS instances?
Not sure.
Yeah.
Baremetal service.
Yeah.
I've never used it.
Yeah, I don't know. Hat or T-shirt?
What size is it?
I have a medium and a small. Or no, a large and a small. Almost. All right, any other questions? There's a hat and a T-shirt. No? Oh, go ahead. Yes, you may. Was that your question? Well, here, since you had the moxie to ask that, you can have the hat. All right, I got one more shirt left for a person small of stature, I believe. Yes. Edge computing. You guys know about edge computing? It's awesome stuff. Go ahead.
So bringing new people into a project is always important. What is OpenStack doing on that front right now?
The upstream, you mean, or?
Bringing in contributors, bringing in community in general.
I don't know, honestly. I'm not that tied in with the upstream project. If you do want to look at the upstream stuff, you can look at the OpenStack Foundation, and their distribution of OpenStack is called RDO, and it's, I forget what RDO stands for, RPM something OpenStack, I don't know, whatever. But it'll run on, you can install CentOS, whatever, put it on. Anyway, yeah, you can check there to see what they're doing. And the hat guy. I don't think I could clear that. You can come up afterwards. All right, any other questions? I'm out of stuff, so it's got to be a real question now. I don't know, not just something to get a hat. Okay, cool. Thanks, guys.